Kathryn Goodenough is a principal geologist at the British Geological Survey and deputy director for BGS Global. She did her undergrad at Oxford and went on to complete her PhD at the University of Edinburgh on the petrogenesis of intrusions in southern Greenland. After that, Kathryn took a rare knack for combining field geology and igneous geochemistry and used it to unravel a series of geological histories in cratons around the globe, in Greenland and Africa, Madagascar. She also worked on the Oman UAE ophiolite, which is actually how I got to know her as my PhD examiner. More recently, Kathryn's been focusing increasingly on the geology of critical metals used in modern technology, like those Xboxes, in particular the rare earth elements in lithium, and as well as how accumulations of these elements can be sustainably developed into mineral resources. So that's what we're going to hear about, I think. Kathryn, thanks so much for coming on. The virtual floor is yours.
Thanks very much, Tom. And I think I'd like to say, first of all, thanks so much to Tom and Alana and everyone else who's been involved in putting together Ore Deposits Hub. It's been a really good platform for the community to come together during these strange times. So I'd like to talk about, I guess, an aspect of the raw materials industry that we really hope, looking at what Aileen was talking about, we really hope is going to bounce back quite quickly because it is so important for the low carbon transition. And that's lithium. And I'm going to talk about lithium pegmatites in Africa. Now, what I really want to do here is give you quite a high level overview. There's over 150 of you listening, and I know that some people know more about pegmatites than I do, but others probably are quite new to this area. So we've been reviewing lithium pegmatites in Africa, and this is work that I'm doing with my colleague Richard Shaw at BGS and with Paul Nex and Judith Kinnaird at the University of the Witwatersrand. Paul and Judith are on the call, so if I get any difficult questions, I'll be going straight to them. Because this will be quite a high-level overview, if you want to ask any questions or discuss anything, then my contact details are there, both my email address and my Twitter name. So please feel free to contact me. And I should just say that as well as the four of us named here, of course, there's a huge amount of collaboration with mining companies and geological surveys in the different African countries that we've been working in. And I'll mention those as I go along. So first of all, why lithium? Why do we care? I should think most of us know the answer to that. Of course, lithium, an essential ingredient in lithium-ion batteries used for energy storage and most particularly, of course, in electric vehicles. And governments around the world, like the UK government shown here, have got strategies to move towards getting rid of petrol and diesel cars and moving to electric vehicles to enable a low carbon transition. And that leads to headlines like this one here that I've been using for quite a while now, Carmageddon, which came when there was the decision in the UK to ban petrol and diesel cars being sold by 2040. So lithium is going to be really important for the future. There's absolutely no doubt about that. And in terms of increasing demand, well, this is the International Energy Agency's electric vehicle outlook for 2020. And this shows you how global electric car stocks have increased over the last 10 years. Tremendous growth in electric cars. And of course, all those electric cars have batteries that need lithium. Now, as we've just heard from David and Aileen, there's going to be a blip in 2020, no doubt about it. Manufacturing is going to have gone down along with raw material production. But I think all commentators agree that we're going to see that as just a blip and that electric car growth is going to continue for some time to come. And what that means, of course, is that there's going to be growth in demand for the battery raw materials, including lithium. And this is the new 2020 report from the World Bank Group on Minerals for Climate Action, talking about the mineral intensity of the clean energy transition and talking about the fact that the more ambitious we are on reducing CO2 emissions, the more minerals we're going to need, and in particular, the battery raw materials. So highlighted here, you can see on the left of that diagram, graphite, lithium, and cobalt, all needed in batteries. And lithium, the World Bank is forecasting an increase of almost 500% in demand by 2050. That's a lot of extra lithium that's going to have to be mined. And because I'm talking chiefly about Africa, this is a really important quote from that World Bank Group report. Demand for these strategic minerals could provide new opportunities for resource-rich developing countries, enabling them to meaningfully contribute to the clean energy transition. And as I'm going to show you, I hope you'll realize that Africa as a continent is undeniably resource-rich when it comes to lithium. So where do we get our lithium from at the moment? Well, this is the USGS statistics for 2018, highlighting the different countries where lithium was being produced. And about half of our lithium supply, it's quite hard to work out the exact amount, but around half of our lithium supply comes from South America, from the lithium triangle, from evaporative brines in the salars, mostly in Argentina and Chile. There's also some brines being produced for lithium in the USA and China. That's a really important part of the global lithium story, but not one that I'm going to talk about further today. Because the other half is what I do want to talk about, and that is lithium coming from hard rock sources. Those hard rock sources at the moment are particularly pegmatites, although there are plenty of other possible sources, but I won't go into those today. And at the moment, the vast majority of lithium mined in pegmatites comes from Australia. But there's a few other countries producing, some in China and some in Zimbabwe. The picture there is the Bikita mine in Zimbabwe, which I was lucky enough to visit with Paul and Judith just really before lockdown back in January this year. There's a small amount of lithium was being produced in Namibia in 2018, but at the moment there's been no production for the last year or two. So some of you will be very interested in lithium, but may not know that much about pegmatites. So we'll just go back quickly over what pegmatites are. Pegmatites fundamentally are igneous rocks that are composed of very coarse crystals. So rocks that formed from magma, from molten rock, cooled to form very coarse crystals. And when I say very coarse, here's an example. That's my co-author, Richard Shaw, in a pegmatite quarry standing next to a crystal of biotite mica that is approximately as tall as he is. And he's probably about 5'10" or so. So it's a pretty sizable crystal. And that's typical of pegmatites. But there's many more things to them than just coarse crystal sizes. They're characterized by a range of unusual textures, directional growths of crystals, graphic intergrowths, all sorts of complexity in their textures and their mineralogy. And that's because they form not just from typical fairly dry magmas, but from very volatile rich magmas. So they're forming at the magmatic hydrothermal boundary. And this has caused a lot of debate by people studying pegmatites over the years. You can get pegmatites for a range of compositions, but the majority of them, and all the ones that are really of interest to us for rare metals, are of granitic composition. And there's a huge amount of work that's been done on the classification of pegmatites, and they can be divided up into a range of families or classes. But we're just going to think about LCT pegmatites. That's a specific subset of the world's pegmatites that are enriched in lithium, cesium, and tantalum, hence LCT. They're also often enriched in beryllium, boron, and sometimes in tin, and have provided a lot of the world's tin over the years. Now, there's been a lot of research on the processes by which pegmatites form. There's a range of reviews. There's a good one recently by David London in 2018. I will put the references up towards the end. And I'm not going to go into all of that in very much detail. This is more of an overview of African pegmatites. But there is one question that I want to highlight, and that is, how do those pegmatites actually form? How do you get these very volatile rich, lithium rich magmas? And where would you go to look for your LCT pegmatites? Well, they occur worldwide. They're on every continent, but they are temporally and spatially linked with orogenic belts, so zones where you've had continental collision at some time in the past. And they form in zones where the crust is thickened and therefore able to melt. Now, there are two really significant models for the formation of pegmatites, and particularly these LCT pegmatites. And these models are, if you like, they're a continuum. These are end members of a continuum. The first, a more established model, is that all pegmatites form from a parental granite body. And the pegmatites form in zones so that your LCT your lithium-enriched pegmatites form furthest away from that granite body. This is a nice image from the paper by Bob Linen and others in Elements in 2012 in the Pegmatites issue. So that's the kind of more established model, but the model that is, I think, gaining more traction is that pegmatites, lithium pegmatites, can also form by partial melting of metasedimentary crust. You don't need a big parental granite body. If you've got enough thickened crust so that the crust is able to melt in a continental collision zone, then where you have the appropriate metasedimentary source that is rich in things like lithium, cesium, tantalum, boron, beryllium, if you partially melt that crust, the idea is that you can also produce pegmatites or the parental magmas of pegmatites. Now, I would say that both of these models clearly exist in nature. There are some places where there's no doubt your LCT pegmatites are related to parental granites, but there are also some places where you are clearly getting pegmatites formed by partial melting of local crust, and only in certain areas where an appropriate source is available are you getting LCT, rare metal enriched pegmatites. And then stepping away from that towards pegmatite mineralogy. Now, this is a very, very complex story. LCT pegmatites can contain a really wide range of different ore minerals. So for lithium, for example, it's not a question of you just mine lithium. You have to mine a lithium ore mineral, and that can be a range of silicate minerals such as spodumene, petalite, eucryptite, lepidolite, and there are also other lithium phosphates, for example, that will occur in those pegmatites. And you have to, if you're working on these pegmatites, you have to be able to recognize all these different minerals, which I can tell you is quite a learning curve. So we've got spodumene there in the top picture, which is more long bladed crystals, and then these heavily cleaved petalite crystals. I'm very lucky to work with Paul and Judith, who are far better at this than I am. So spodumene at the moment, if you look at a pegmatite mine in Australia, it's most probably producing spodumene, and that is being processed to produce lithium carbonate and lithium hydroxide for batteries. Processing for other lithium minerals is a bit more perhaps in its infancy, if you like, in terms of producing the battery chemicals, although some of those minerals are widely used for other uses, such as petalite being used in ceramics. So in your pegmatite, you might have all these different lithium minerals. They might be very integrating with each other. You may also have a whole range of other minerals that, of course, could be useful as well in terms of byproducts. They may be rich in cesium, they may be rich in tantalum, tin, beryllium. So pegmatites are complex, but can have this real store of rare metals. Now, what happens if you mine your lithium pegmatite and you produce your spodumene? Well, you're going to concentrate it at source, most likely. But then this diagram, which shows the trade flows for lithium for batteries, which comes from Evi Petorazzi and dates back to 2017. You can see all those orange arrows. That is lithium carbonate being produced in South America at the brownfields and being sent mostly to Asia for making into batteries and other components. And then this big yellow arrow is showing you lithium, is showing you spodumene concentrate being sent from Australia to China. That's because pretty much all of the world's spodumene currently has to be processed in China to turn it into the lithium chemicals that are needed for batteries. So that is, if you like, a real bottleneck in the supply chain, in that everything is going through China. China does control this supply chain, even though we may have production in a range of different countries. If you're mining petalite for ceramics, you're more likely to be able to process that at source and sell the product directly. So understanding supply chains is a really important part of all of this. And although most of what I want to talk about now is geology and African pegmatites, it is really important to understand this, that supply chain, the mine is very important, but you have to think about all those steps in the supply chain to really be able to make a difference in resource-rich developing countries. So I'm going to step over into some geology. And why are we interested in Africa? We're really interested in Africa because this is a continent that is incredibly prospective for LCT pegmatites. It really has the classic geology that you need. And I'm going to give you a bit of an overview of that and then go into some detail and look at some of the projects that are out there being investigated in Africa. So the African continent is made up of a patchwork of Archaean cratons, which are shown in this diagram in pale pink: the Kalahari craton in the south, the Congo craton, the Tanzanian craton, the West African craton, and then a range of other smaller cratonic nuclei. And those are stitched together by, in pale blue, the Palaeoproterozoic mobile belts, and then in the purple, you've got Neoproterozoic mobile belts associated with the Pan-African orogeny, the formation of Gondwana, if you like. So Africa is, if you like, you've got all these central cores that have been pushed together over time through a range of orogenic events. And those orogenic events are when you have the pegmatites forming. And I'm just going to show you there's different groupings now. So in the Archaean, at first, we have pegmatites in the Kalahari craton, and I'm going to talk about those in a bit more detail shortly. Then you come into the Palaeoproterozoic. The Birimian of West Africa is associated with LCT pegmatites. You come into the end of the Mesoproterozoic, start of the Neoproterozoic, and in the Kibaran of Central Africa, you've got substantial LCT pegmatites, some of the world's largest, in fact, and some of the most significant. But that also extends down along the margins of the Kalahari craton into Namibia. And then finally, you come into the Neoproterozoic, almost into the Cambrian, in the Pan-African orogenic belts. And again, significant LCT pegmatites. So they really are spread across much of Africa. And I should just highlight that these pegmatites have mostly been dated, and a lot of review work has been done by Frank Melcher and his team at the University of Leoben, who have been doing a lot of work on coltan in these pegmatites. And their work really underpins an awful lot of our understanding, our broader understanding of pegmatites in Africa. And I'll be mentioning some of the other research groups as I go through. So let's focus in, starting from the oldest part of that geological timescale, and look at some of the LCT pegmatites that are out there. So in the Archaean cratons, pegmatites are typically found in the greenstone belts, where you've got metasedimentary rocks available to melt and produce the pegmatites. And LCT pegmatites of Archaean age are best known in the Kalahari craton of southern Africa, especially in Zimbabwe, but also elsewhere in South Africa as well. They've not been particularly well described in other African cratons. And one of the questions that I think is really important is that because of evidence of absence, or is it in fact absence of evidence? You know, the Archaean cratons across much of Africa are very heavily weathered. And we know that weathering tends to dislodge lithium from its minerals pretty quickly. So we've done some recent work. We're working quite extensively with colleagues in Sierra Leone, which is on the West African craton, and in the greenstone belts in the Archaean craton there, we have indeed seen LCT pegmatites. There's my colleague Richard Shaw standing looking at a rather lovely spodumene pegmatite, but really there's only a few boulders available. And when we look at samples, what we see is that there is spodumene, but you can probably see this spodumene crystal here is really quite spongy and quite corroded looking. And we think that's down to the tropical weathering. These are surface samples. Really, my understanding is certainly in West Africa and in other parts perhaps of Africa that have tropical climates, you really need to drill, because the upper part of the sequence, the soil, the lithium minerals are going to have broken down, and the lithium is likely going to be washed away. It's a very, very fluid, mobile element. So it may be there's a lot to be discovered in the Archaean cratons in Africa. But one craton where we already know that there's plenty of LCT pegmatites is the Zimbabwe craton, the northern part of the Kalahari craton. This is a simplified map of Zimbabwe, geological map. And the pink shows the Archaean craton. I don't have the detail of the greenstone belts in here. Zimbabwe has abundant and extensive greenstone belts. And within those greenstone belts, there are several major pegmatites of Archaean age, either dated or presumed to be Archaean. They include Arcadia, Bikita, Sabi Star, Zulu, several others. It's a really extensive list. Also in Zimbabwe, I just have to highlight this because I visited in January. There's some amazing archaeology. I do recommend it as a place to visit, but this is Great Zimbabwe, a 1,000-year-old archaeological site on that Archaean craton of Zimbabwe. So a place that's well worth visiting. So let's have a look at the first one of the projects that is an LCT pegmatite that is being developed pretty rapidly. And this is the Arcadia Project, close to Harare, licensed to Prospect Resources. And I think Roger from Prospect is on the call. What we've got here is a series of gently dipping stacked pegmatites, which are actually not dated, but they are assumed to be Archaean. They're in a greenstone belt, in the Harare greenstone belt, in fact. They have Southern Africa's largest JORC-compliant lithium reserve at 26.9 million tons at 1.3% lithium oxide. As you'll see as we go through, the percentages remain fairly similar throughout. And at Arcadia, there's real potential because of the mineralogy. They have both low iron petalite, which is useful for ceramics, and spodumene, which can be used in battery production. So this is a really interesting project that is developing fast, hopefully towards a mine in the not too distant future. And Roger, kindly, thank you very much. Roger sent me this diagram, which illustrates a really key point. So this is a cross section through the Arcadia project. It shows the drills and the intercepts. Most importantly, I think, it shows you that there's this series of stacked pegmatites, and that is what we tend to see at most LCT pegmatite prospects in Africa. You might be able to see one pegmatite at surface, but if you've got one, the chances are that there will be a whole series of them, likely parallel. So really, again, it's an emphasis on how much you need to drill to understand these kind of pegmatites. So the other important, really important LCT pegmatite in Zimbabwe is Bikita. And Bikita is Africa's only producing lithium mine. And here we've got several open cast pits along a large, irregularly zoned pegmatite with several other pegmatites around in the area. There's your geological map, which dates back to 1964 and is still the best geological map being used in the area today. So that kind of gives you an idea of how much work there could be to be done in these areas. Bikita is dated, it's Archaean in age, 17 million years, and again, intruding a greenstone belt, the Masvingo greenstone belt. And here's some photos. We were at Bikita in January. Bikita has pretty much every lithium ore mineral that you might want to see. It has petalite, which is currently sold for ceramics. It has spodumene, it has lepidolite. It also has tantalite for tantalum and pollucite, which is the cesium ore mineral. And they have identified a spodumene resource that is yet to go into production of 13 million tons at greater than 1.6% lithium oxide. And Bikita is a place where you can see quite complex zonation, which is really rather irregular and quite hard to map out. And some really classic pegmatite textures here. We've got great examples of line rock, these kind of layered aplites, if you like, and also directional growth of crystals of lepidolite coming off that line rock. This is really impressive because not all LCT pegmatites have these kind of classic pegmatite textures. So moving up the geological column now and switching over to West Africa, the Palaeoproterozoic in the southern part of the West African craton, the Leoman Shield, is termed the Birimian. And this is a figure from a paper we published on the mineral resources of Liberia in 2018. And this shows you a range of different mineral deposits in the Leoman Shield highlighted. It doesn't show you any pegmatites at all. We completely missed to mention that. Actually, this is a Palaeoproterozoic volcano-sedimentary sequence intruded by abundant granitoids. And indeed, there are LCT pegmatites and really some very impressive lithium projects in the area. So in Mali, in the Buguni area, there's several different lithium prospects, including the Goulamina pegmatite. I'm not going to talk about that further, but we have samples from it. And we have collaboration with the University of Bamako on that. Ismaila, I think you're on the call, and we're looking forward to potentially working more on this. The other project in the Birimian that's really important is the Ewoyaa project and other associated pegmatites close to Cape Coast in Ghana. And the Ewoyaa project is under license to IronRid Resources. I think Ewan from IronRid is also on the call. And I was lucky enough to visit towards the end of last year. So in this area, again, we've got several LCT pegmatites intruded into the metasedimentary rocks of the Birimian. And these haven't been dated, but they're likely about 2,080 million years old. That's consistent with the age of magmatism in the Birimian terrains. And they're pretty close to some granitic plutons at Cape Coast. So were they formed from a parental granite or by partial melting of the liquid crust? We don't have an answer to that. Here, there's a really distinctive feature to these pegmatites, which is that they have spodumene as the main ore mineral and not much in the way of other lithium or cesium or tantalum minerals. So you've got the large bladed crystals in the field photo here. And this is a rather poor photo of the core that I took, apologies, but you get the point. These kind of slightly bronzy crystals here are big spodumines. This is a intensively spodumene-rich pegmatite. And somewhat different in that respect to Bikita. You don't see so much zoning in these pegmatites either. So another really interesting and important lithium project, but different in terms of age. Moving on up the geological column, and we come to the Mesoproterozoic and the Kibaran of Central Africa. Now, this is a really well-known LCT pegmatite belt. It's been known for a long while. There's abundant pegmatites in the Kibara and Karagwe and Koli belts, which are up here in between the Tanzanian craton and the Congo craton. And this area includes one of the world's largest lithium pegmatites, Manono Kutolo, in the DRC, which has a resource of 400 million tons at 1.65% lithium oxide. That's a lot. Now, this has been described in some detail by Stein de Vela et al. In 2016. And at this point, I should say that I'm not going to talk much more or any more really about the Central African pegmatites, because it's not an area that I visited, but also our Belgian colleagues have done a tremendous amount of work on this. The teams from KU Leuven, Ghent University, and the Royal Museum for Central Africa have been working on these pegmatites for a long while. And there's some superb papers out there that I recommend looking at. This is probably the best known area of LCT pegmatites in Africa. But what I do want to highlight is that that's the known Kibaran orogenic belt. But down here, you've got the Eremite belt. And it is interesting that there are also pegmatites of this kind of age in this area, particularly in Zimbabwe, and then down in Namibia on the Namibia-South Africa border. And those are rather less well known, and they show that this was a very extensive period of lithium-rich magmatism. And it's this pegmatite here, Kamativi, that I want to mention further. So Kamativi is in northwest Zimbabwe, and this pegmatite has been well dated, and usually it's actually been dated by two different groups and they got the same age. That's a good set of knowledge, if you like, for a pegmatite in Africa. It's 1,030 million years old, and the really interesting thing about Kamativi is that it intrudes Palaeoproterozoic rocks around 2 billion years old, and all the granites in the area are also around 2 billion years old. So there's no obvious parental granite for Kamativi. You've got a pegmatite that's about 30 meters thick and very laterally extensive, and yet there's no sign of any parental granites. So that's a really important one to understand the difference, if you like, between the two models of how LCT pegmatites might form. Kamativi was mined for tin up until 1994, and Zimbabwe Lithium is now looking at the tailings from that tin mining. And you can just see here the pale coloured hill is in fact the tailings pile. And they have identified a resource of 26 million tons at 0.58% lithium oxide in those tailings. Now, Kamativi is very unlike Bikita in that it's much simpler. It has marginal zones, and then it has a thick lithium-rich core with tin and tantalum. These big crystals are alkali feldspar in the central diagram, but in between there are bladed crystals of spodumene. So there was abundant spodumene in that core. And you can see some layering here, which is really represented by almost albite-rich layers in between the spodumene-rich layers. And we will come back to that. So moving on up the geological column again, and thinking about the Pan-African. And that's the purple areas on that map, if you like. So it's the belts that knit together the whole of Africa. And LCT pegmatites of various kinds are common throughout the Pan-African belts. I've just highlighted a few here: Nigeria, Ethiopia, Madagascar, Namibia, Mozambique. And there are many other areas where you have Pan-African pegmatites that show LCT type enrichment. But not that many of them are really that lithium rich. Many of them are enriched in tin or in tantalum. In Madagascar, it's mostly about the gemstones. So you see quite a lot of variation in the Pan-African pegmatites. In general, they are similar age to abundant Pan-African post-collisional granitoids, but not by any means the same in terms of age. So the lithium enriched areas really are, there's three particular zones that are lithium projects, if you like. There's Belgrano in Mozambique, there's the Karibib projects in Namibia, and there's the Kenticha pegmatite in Ethiopia. That's not to say there aren't other lithium enriched pegmatites, but those are the three main areas that are being explored at the moment. Now, the reason that I got into pegmatites right from the start was in Nigeria. This is the first pegmatite I saw that was being artisanally mined for tantalite. That's in Nigeria. I was there about 10 years ago. And we went to look at the Pan-African granites, but we found the pegmatites to be very interesting, particularly when it became apparent that although they're close to the Pan-African granites, they are actually substantially younger than them and geochemically really quite different. And that was what first, if you like, set me on the path that made me think perhaps not all LCT pegmatites are related to parental granites. I could say the road goes ever on and on because we certainly haven't answered that question yet. So just looking at one project in the Pan-African, if we go to the Karibib projects in Namibia, and these are Paul Nex's photos here, there's a series of pegmatites there, including Rubicon and Helicon, now under license to Lepidico. There's a total resource estimate for the area of 11.24 million tons at 0.43% lithium oxide. The really interesting thing here is that spodumene is not really a player, if you like. The lithium minerals are lepidolite, lithium mica, petalite, and bligonite. And many companies would say, oh, well, you know, that's less interesting than spodumene. But Lepidico has developed technology to leach lithium from micas. And that is potentially going to be really important into the future. And Lepidico are supporting a grant proposal we have in at the moment so that we hope to be able to work with them further in the near future. So that's a very quick summary of African pegmatites and how they fit into the geology of Africa. And I just want to show you a couple of slides really on LCT pegmatites and some of what we know about their evolution and how the mineralization forms. And the answer is, of course, there's a lot of questions. So the source of the lithium-rich magmas continues to be debated. Sometimes it may be parental granites, sometimes it may be partial melting of local metasedimentary crust that is already rich in lithium. Much more work to be done there. Some of these pegmatites show quite impressive zonation, often irregular, as at Bikita. Some just have a very simple zonation. They have a margin and then they have a core, and the core tends to be rich in the lithium minerals, for example, spodumene or petalite. And those minerals often seem to form quite early in the magmatic evolution of the pegmatite. And the normally accepted concept is that whether you get spodumene, petalite, or eucryptite is controlled by pressure and temperature. But there's some recent work that suggests maybe it's not that simple. I think it's fair to say in pegmatites, it's often not that simple. But then the really interesting thing is that as that pegmatite evolves, you start getting immiscible fluids, and you start seeing an awful lot of hydrothermal alteration. Typically, albertization and grisonization are really common. And we're starting to see this in some of the African pegmatite samples that we have. But David Keita, who was on earlier talking about the impacts of COVID-19, he's been working on pegmatites in Ireland with the team at UCD and with Renata Barros. And they've really done some detailed study of this, and they're seeing much the same thing. These late stage hydrothermal fluids or deuteric fluids are causing albertization, grisonization, and maybe introducing some of the elements of interest like tantalum and tin. But it is possible they may be removing lithium from some of these pegmatites. So these two images here are from Kamativi. You can see quartz. Everything else looks a bit destroyed. We've got what was probably once spodumene quartz intergrowth that has now been completely replaced. And we've got an albite vein, bladed albite, running across the thin section. And then this lower image here shows what was once a spodumene and is now a complex intergrowth of spodumene, albite, zeolites, quartz, and all sorts of other things. These images are taken by my colleague Richard Shaw, and I should say that our samples from Kamativi he's been working on, but almost all of our other work has been somewhat disrupted by COVID-19, unsurprisingly. Some samples that were in for work in the labs, it's obviously been impossible to do that. And our samples from Bikita and Arcadia are sadly still in Harare, where we hope we will eventually be able to get them back from once the lockdown improves. So in terms of understanding the processes of magmatic mineral growth and then alteration and mineral destruction, there's a lot more work to be done. But as I say, David in particular and Minato Barros have written some great papers on this kind of topic. And just to show you briefly, in terms of the type of data that we're going to be collecting to compare the different African pegmatites, this is just a plot of muscovite chemistry, potassium over rubidium versus cesium. And this seems to be a really good indicator of prospectivity for lithium. You can see down here, Bikita. This is the mineralized part of Kamativi, and here are some samples from Gulamina, and all of these are mineralized for lithium. But you look at the marginal samples from Kamativi or some samples from those pegmatites in Nigeria where there's artisanal mining of tantalum, but really no significant lithium interest. And you can see that they plot further up into this quadrant. So we hope to build up a lot more data onto these plots to be able to show how you could use muscovite chemistry, perhaps even in muscovite that's on the surface, to understand what your pegmatite might be like at depth. So that's really all that I wanted to show you now. And I've called this slide conclusions, but then I called it questions for the future. I thought that was a much better description. So in terms of LCT pegmatites and lithium prospectivity in Africa, I've said, will exploration in Africa identify more major LCT pegmatites? And my feeling is yes. The answer to that is yes. There is more out there to be found. But what are the best techniques to use? That's an important question, because some of the techniques that we might normally use, like soil geochemistry, don't seem to be that useful because lithium is so mobile that it can just be washed away in the soil. So identifying the best exploration techniques is going to be important to be able to identify the lithium deposits of the future. Understanding the major control on the magma source. Is it about parental granite, or is it all about the source materials being there and being available to melt? And what are the best source materials for an LCT, for a lithium-enriched pegmatite? All of these questions will help us build up exploration models. Why do we get different lithium minerals? Why spodumene or petalite or eucryptite? Is it just pressure and temperature? Why do we get lepidolite in some pegmatites and not in others? These questions still need to be answered. And can we draw all of that together to identify exploration indicators that will help us in targeting lithium-rich pegmatites, or indeed tantalum-rich or tin-rich or even gemstone-rich pegmatites? And then my final question is really going back to that World Bank quote. What are the opportunities for African countries here? There's extraction of raw materials, of course, but what about the rest of that value chain? Is it going to be necessary to send spodumene concentrate to China from West Africa? Or is there potential for something further in African countries, something that allows them to move along the value chain? And I've put in this photo from Ghana, from the IronRid Resources project, to point out that, of course, Africa doesn't just have raw material resources, it has tremendous human resources. And a lot of people, and I know there's some fantastic people listening to this talk, who really could be getting involved in developing that African value chain for lithium. And I think that's an area that we're also really interested in working on in the future. And I'd just like to finish up by acknowledging all the companies and geological surveys that have helped us so far in looking at different African LCT pegmatite projects, exploration projects and mines. And there's just a list of references there. And that's me. Thank you very much.